Okay, well, thank you for staying. People who know me know that I get excited very easily by fungi, and the aim of this evening's talk is to see whether I can get anybody else excited. The first thing, of course, is to find your fungus. Now, if you're a beginner, then finding any fungus is exciting. If you're a little more experienced, then it's still exciting, but we're looking for better specimens, perhaps specimens that are a little bit unusual and we haven't seen before. After the excitement of finding comes the excitement of identification, or I have to admit, the frustration of identification. And if those of you who consider yourself beginners think you're the only people who get frustrated by trying to identify fungi, you're quite simply wrong. Everybody who tries gets frustrated at some stage. But there is satisfaction in success. One of the problems with identifying fungi is that they are very variable, and it's often very difficult to tell where the variation stops and another species begin. But again, it's not just the beginner who has problems. These problems have not always been resolved at the highest level, so there is real doubt in some cases. But no doubt, but there is no doubt a great satisfaction in coming to an answer. Now, some fungi are extremely easy to identify and can be identified by comparing the specimen with an illustration. Sadly, that's not true for lots of species. But here, for example, the fly agaric, doesn't everybody know what it looks like and knows what it's called? I think so. There are a few other fungi, much less common than this, which have an iconic existence. That is to say that people have an image of them, although they may not have seen them in the wild. And one such fungus, in 2017, I received this photograph and an email from John Alban, who had found this fungus on his lawn in Heatherset. Now, Dr. John Alban is not a naturalist. He is, in fact, a retired county archivist, Norfolk County archivist. He lives in South Wales, but he keeps a house in Heatherset for when he wants to do some quiet writing. And this appeared on his lawn. In fact, several of them appeared on his lawn. And at first, he didn't know what it was. He thought it was rather disgusting, and he scooped it up and put it in the bin. But then, being an academic, although not a naturalist, he looked more carefully and decided it just could possibly be a fungus. Now, if it's a fungus, what would it be called? And he thought, well, it might be called a basket fungus. And so he Googled basket fungus and discovered exactly what he had found, which was the white basket fungus. What he didn't know at that time, although he did realize that it was far from common, was that its native area is Australasia, Australia, New Zealand, and the tip of South America. And in New Zealand, at least, it's an extremely common fungus. It occurred in this country first noted in 1955 in southwest London. And since then, it's appeared most years in gardens in about a 10-kilometre arc in that area, and very occasionally indeed elsewhere in the country. So quite how it got to John Alban's garden, we will never know. It's related to the stinkhorn. You'll be perhaps familiar with the rude fungus, the one that smells awful. This white basket fungus also smells awful, but the slime, instead of coating the head of the fungus, coats the lattice work, and in the same way attracts flies. Interestingly, when it emerges, it breaks completely free of its mycelium. So it hatches from an egg, like our stinkhorn, there's the egg, and it springs out. As the pressure builds up, suddenly the basket jumps out of its egg and is completely separated from its mycelium. Indeed, in New Zealand, certainly it blows around, and this rather like tumbleweed, and this may help dispersal. Another fungus, which people who are interested in these things will know from a picture, but may never have seen in the wild, also an Australasian fungus, has occurred in Britain rather more commonly along the south coast. But in 2019, Harvey Hill, a 10-year-old lad, found this in his mother's allotment at East Runton. I was contacted, and I was able to go and take a photograph of this devil's fingers. This is also a phalloid fungus, that is to say, it's related to the stinkhorn, but this time it stretches its fingers out of the egg, all coated with foul-smelling slime. The slime there is the black bands, and they attract insects that eat the spores and disperse the fungus. This fungus does seem to be increasing in frequency in Britain. Has now been recorded from Northern Ireland. Because we never know whether a fungus like this, known from Australasia or Southern Hemisphere, always assume that it has moved from there to here. But it's logically possible that in fact it's a British fungus or a European fungus that was moved to Australia or New Zealand and has become more abundant there than where it originated. Moving on now to the excitement of discovery. That is rather more than just recording the presence of a fungus, finding out something about it. A couple of stories here. In 2019, November 2019, Ian Senior, who records avidly fungi at Earlham Cemetery, sent me this photograph of a brown mushroom-type fungus with obvious problems. And it was the problems that we were initially interested in. Well, a few weeks later, it looked like that. So the question is, what was going on? I didn't know. But surprise, surprise, the next week, I received that photograph from Andy Gardner and Tracy Money at Ashwellthorpe. And it looked as if it had the same problem, but what was the problem? Well, what you do when you're stuck is you phone a friend or you email a friend. And I contacted people I know at Kew, and they offered a few suggestions, but none of them seemed to work. Fortunately, one of the people who saw this at Ashwellthorpe was Anne Edwards. And Anne professionally is a molecular biologist who is able to sequence DNA. More of that later. So I had found in the surface of these toadstools a evidence of another fungus. So it looked like a fungal infection of the mushroom. And Anne was able to sequence the fungus that was doing the infecting. Well, you say, the problem should be solved. And in a sense, it has been. Because then with that sequence, it's possible to look online to see whether any other fungus with that sequence has been found. And to everybody's great surprise, the answer was it has, but only once, in Oregon, North America, and it was the DNA sequence of something really quite different, of another parasitic fungus, which had been given the name Mycosymbiosis mycenophila. Mycenophila means mycena loving. Mycena is the genus of bonic fungi. And we were able to contact Jonathan Frank, who had found this fungus, done the DNA and published it as a new species, but it looked absolutely nothing like the Norfolk bubble fungus. So what's going on here? Well, this photograph shows the fungus looping down to the lower part, attacking the base of a bonnet fungus. And what is almost certainly the case is that this is the sexual form producing sexual spores. And what we have in Norfolk is the asexual form producing asexual spores or conidia. It's quite common for fungi to have completely different sexual and asexual forms. And in some cases they alternate, in other cases they don't. And this seems to be a case where the forms don't alternate. But it would be very interesting if we could find the sexual form here, or if Jonathan or anyone else in Oregon could find the asexual form there. So a partial solution, but still a puzzle. This one goes back just a little bit further, but again required professional help from professional mycologists to make the discovery. These rather nondescript little mushrooms were photographed on the dunes at Blakeney Point. We were able to identify them as webcaps, Cortinarius species, but two problems. One is that webcaps are extraordinarily difficult to identify to species. And secondly, at that time, all were known or thought to be mycorrhizal with tree species. And there aren't any trees anywhere near this site on Blakeney Point, not even birch seedlings. So that was a bit of a puzzle, which was left aside until we saw that an Irish mycologist, professional Irish mycologist, had established that a very closely related species, it actually turned out to be the same species as this fungus, was mycorrhizal with sedge species in the Burren and Western Ireland. And so Anne Edwards again came to our rescue, and she was able to find the DNA of the fungus species inside the rhizomes of sandsedge. If you look at the bottom left-hand corner, I don't know if my pointer can be seen by you, but this plant here is sandsedge. So the two are growing close together, and found the DNA of the fungus inside the rhizomes of the sandsedge, suggesting that this was another example of a webcap making a mycorrhizal association with a sedge. And that may be, there may be other species. It also led to the identification of the fungus because also contacted the Royal Botanic Society, Royal Botanic Gardens of Kew, and Tula Niskanen, a research worker specializing in webcaps, Cortinarius species, was able to put us in touch with a French mycologist who had sequenced the type species of Cortinarius pratensis, and got exactly the same sequence that Anne had got from our specimens. So we were able to establish that this fungus was Cortinarius pratensis and that it was mycorrhizal with sandsedge. Now this embarrasses me a little. Why should naturalists, maybe it's a human trait, we seek out the unusual, maybe it's a survival mechanism, I don't know. But rarity has some sort of a cachet for most naturalists. So, as far as Norfolk is concerned, it's always exciting to find a species which hasn't been found in Norfolk before, even more exciting to find one that hasn't been found in Britain before, and perhaps the ultimate excitement is to find a species that hasn't been described before. Problem is, if it hasn't been described, it's actually very difficult to identify it or to get anybody to do that for you. So this fungus here, which the circumstances of finding were slightly strange. I was leading a foray in a garden near here, which had been opened for a meeting of a plant society, a garden society, and it was a large garden, and a lady holding this fungus and saying a little shyly, have we seen this before? I assured her that I had never seen anything like it before. And it took a little bit of sleuthing to find out that it was, in fact, the Amanita inopinata. Now, inopinata, I'm told, because I failed Latin O-level, but I'm told it means unexpected. And that name has been used for the English name. So it's the unexpected Amanita. Those of you who know something about fungi will not have immediately recognized this as an Amanita. It's these pale peachy gills, the flakes on the cap. It was first described to science only in the 1980s, a specimen in Essex, and given the name. Since then, it's been found once or twice in Britain, but it just pops up unexpectedly, and it doesn't even look like an Amanita. Right. Another first, sorry, that wasn't a first for Britain, but this was. A friend of mine who keeps hens, she was living at the time at Bristol, not far from Holt, knowing my interest in fungi, came round to the house with a jam jar with these ink caps in. She'd found them inside the hen house on the nest box. I thought I could probably identify them, but I couldn't. I knew roughly what they were, and I certainly knew what they weren't. And so again, phoned a friend. This time it was Eric Schaefer, who's the country's expert on ink-cap fungi, and I described them, and he said that he didn't recognize them either. We knew roughly what they were, and so he sent them to his friend in Hungary, who was able to do the DNA work. And this is, in fact, the DNA sequence, again, more of that later, which established that although it's not new to science, it had been found in Canada, it was, in fact, new to Britain, Coprinopsis rugosa bispora. Just a matter of chance, isn't it? The right people being in the right place at the right time. These fungi are not necessarily uncommon, just not recorded. Now, this is pretty well new to science. And I played no part whatsoever in facilitating this one. It started in 2001, I think, when Jonathan Revitt, who's fascinated by Earth stars and knows a lot about them, found these specimens near Cockley Cly. They look very much like the very rare four-rayed Earth star, but Jonathan wasn't happy that that's what they were. So he sent them off to the expert, Dr. Jalink, in the Netherlands, and got the reply, yes, they're a known variant of the four-rayed Earth star. Nevertheless, Jonathan sent the specimens to Kew, where they, the dried specimens, where they put them in a drawer with the label and left them there, which is what always happens when you send fungi to Kew. Until someone has an interest in that particular group. And that arose about 7 or 8 years ago, when Kew had a request from a Spanish group of mycologists who were revising the European Earth stars. And they wanted specimens from different places in Europe of known species to do the DNA sequencing so they could see how they were related to each other. So Kew sent four-rayed Earth stars, including, as it turned out, the one that Jonathan found at Cockley Cly. A few months later, Kew received the email from the Spanish group saying, thank you very much for your four-rayed Earth stars. They all had the same DNA, but none of them had the same DNA as anybody else's four-rayed Earth stars. So Kew, as it were, looked rather more carefully and realized there were some distinctive differences that could be seen. For example, the spore sac is wider in this species than it is tall, and that's quite a distinctive feature. And the Spanish group were able to name this as a new species, Geastrum britannicum. And although it occurs elsewhere in Britain, and it's probably quite widespread, certainly been found in half a dozen different places in Norfolk subsequently, Jonathan Revitt's specimen from Cockley Cly has been designated the type specimen with the description. Now this little brown fungus, which is a lot smaller than it appears on your screen, was found, can't remember the date, just a few years ago. It was found in 2017 by Yvonne Minot, who's with us this evening. And you won't see it in that picture because it's not there. That picture was taken of the place where she did find it, but a little while later. This small brown mushroom was growing on dead reed leaves, which had been trampled into the shallow water. And it turned out to be, once identified by Yvonne, as new to Britain, and found only in a few other places in Europe and elsewhere. Now, the most recent of these rarity excitements is unfolding almost as we speak. This very tiny fungus, now known to be Coprinus parvulus, was found by Mark Joy, who collected some deer droppings, as we mycologists frequently do, from the Broadland Country Park, took them home and incubated them. Incubated is a grand term for simply leaving them in a moist container. Emerged. He tried to identify them, not surprisingly failed, but Yvonne more successfully did identify them and has subsequently had them confirmed as new to Britain by Derek Schaefer. In fact, I believe there's only one other report of them. Can't remember where it is. It's somewhere in Europe. So these are the second specimens known. Now, we'll come in a moment to DNA work, but currently the DNA is being sequenced for this fungus. So, moving on now to future excitements. Where are we going from here? Well, you've already had a hint that perhaps the most exciting thing that is happening at the moment in many aspects of natural history is the possibility of defining species by their DNA sequence. I need to give you just a little bit of background, although I think now that possibly everybody knows what DNA is and what it does. It carries the information which determines how a cell develops and all the characteristics of an organism. And the DNA is in the form of sections of an immensely long strand composed of 4 bases known by their initial letters A, G, C, and T. And it's the order or sequence of these bases along this immensely long chain. When I say immensely long, hundreds of millions of bases. It's the sequence which determines the characteristics of the organism. Now, much of this sequence is quite similar in different species, but some regions show great variation between species. These have become known as barcoding regions, and they're the regions which can help identification and delineation of species. These sequences, these barcode sequences, are typically 600 to 800 bases long, and it's now possible for relatively easily to sequence these barcode regions. So what does that involve? There are 3 main stages. The first is to extract the DNA from the specimen, and this would be true whether it's a fungus, a plant, an insect, or any other living organism. and then to make multiple copies of the DNA barcode region, which sounds an impossible task, but with the aid of certain tricks, it's possible to use a technique called polymer chain reaction, PCR, which maybe everybody knows about now in connection with the COVID DNA RNA identifications, to both find and extract the barcode sequence. And there's a magic box which makes this possible, even for amateurs. And a second magic box enables the user to check that the appropriate DNA has indeed been purified, many millions of copies made. So then stage 2, which has to be outsourced at the moment anyway, and the sample of DNA is sent off for sequencing. And in 24 hours time, an email comes back with the sequence. The third stage, again, can be achieved by amateurs, and this is the interpretation. And this is by far the most interesting stage. First of all, because sequences, once they're determined, are in the public domain. So it's possible to look at the sequence you have and see what it matches up with. But there, the problems do start and the interest develops, because matching up your sequence with a published sequence sounds fine, but who, on what authority was the published sequence correctly identified? If it was an expert in the field, then it's as good as it gets. But anybody can put up a sequence for a fungus or any other species that they have perhaps misidentified. That goes into the database. And so you have to be very careful that you are comparing your sequence with a validly identified sequence. Because the ideal is to compare it with the type specimen, the one that was designated as that species when the species was described. Because literally, that is the only specimen that is unambiguously that species. If you can show that your DNA sequence is the same as that, then you can show that you have the same species. Now, why is this all so exciting? Well, it's exciting because, as I've been hinting, it's now possible for mere amateurs like ourselves to do this work. And through an initiative called the Darwin Tree of Life, which is a national project funded by the Wellcome Foundation, which has two sort of parallel aims. One is, in time, to establish not just the barcoding areas, but the full genomes of all British species. It's an almost impossible task, but that's the aim. And it's taking place now. En route, and in order to help with this, various groups around the country are being trained to do the sample preparation, interpretation, and the barcoding work. We're very fortunate in Norfolk because two of these strands have actually come together. One through the Earlham Institute, called Barcoding the Broads, and another from Kew to the Norfolk Fungus Study Group. And those two are working together. And the consequence is that the kit, these magic boxes, and the reagents needed to use them are now being placed in Norfolk at Wheatfen for the use of naturalist groups who are being trained to do it. Basically, the first stage is just a rather elaborate cooking on a very small scale. And the final stage, the interpretation, we will, of course, need help from professionals. So if you want excitement in your life, join the Norfolk Fungus Study Group. Thank you very much. If you're still hearing me, I could take some questions.